We are going to solve this particular question under the what? The referral in transformers. So first of all, we have been given what certain what data within the question. The question states that what a 50 kVA slash 4400 slash 220 volts. Okay, so the rating of the transformer. So let's have our data. Okay, so data here, and then we have the rating, which is X. So here we can say X is equal to what? 50 kVA. Okay, the rating of the transformer, that's apparent power. 4420, that means that what the primary voltage V1 is equal to what? 4400, right? Okay, and that of the secondary voltage V2 is equal to what? 221 volt. Okay, now the transformer has a resistance R1. So R1 is equal to what? 3.45 ohms, and R2, which is 0.109, which is 0.09 ohms. Okay, the value of the reactances are, so we have with reactance 1 X1, which is 5.2 ohms, and that of the X2 is equal to 0.0115 ohms. Okay, now calculate the transformer I. So let's talk about the I first. I, we should find the equivalent resistance as referred to what? The primary. That is the same as what? X. That is the same as what? R01. Okay. And we are saying that R01 means that we are doing the referral to the primary. And when we are doing the referral to the primary, we have the R1 existing already. And then we are now bringing in what? R2 prime. Okay. So the equivalent resistance will be the summation of the individual resistances since they are in series. Okay, so R01 will now be equal to R1 plus what? R2 prime. Okay, and don't forget that we said R2 prime is the same as what? R2 over what? K squared. So we can see R01 is equal to what? R1 plus what? R2 all divided by what? K squared. So therefore we can move further to say that R01 is equal to, so what's the value of R1? Now we know that the value of R1 is what? 3.45, okay, plus the value of R2. So R2 is 0.009 ohms divided by what? K squared. But we don't have the value of K squared. So let's go and find K. So we know that K is always equal to what? V2 over V1, okay? And that will be the same as what? 220 divided by 4400, okay? And that will give us a corresponding value of, so 2200, which will give us a corresponding value of what? 1 on what? 20, okay? So this means that what? We are going to, wherever we see K, we are going to put in what? 1 over 20, okay? So here we can see R01 is equal to 3.45. Don't forget to square the value, okay? Which is 0.009 divided by K square, which is what? 1 over 20 all squared, right? So the value of R01 will now be equal to, so what's the value of R01? R01 will now be equal to 7 point what? 05. Okay, let me simply do it gradually. So here we can see R01 is equal to 3.45 plus what we have here, which is giving us what? 3.6. Then it means that what? Our corresponding R01 will now be equal to 3.45 plus 3.6, and that will give us 7 point what? 05 watt ohms. Okay. Now let's move on. The second question says that what? We should find the equivalent resistance as referred to the secondary. That means that we are now doing the referral at the secondary. And at the secondary means that R2 is already existing, right? But then we are now going to bring the R1 to the secondary, which will be what? R1 prime. The prime is there based on the fact that it becomes what? A refugee, okay? So here R2, and we know that R1 prime is the same as R1 k squared. So we can say R2 plus what? R1 k squared. Therefore, R02 will now be equal to, we know the value of R2, right? So here R2 is the same as what? 0. What? 009 plus R1, which is what? R1, which is 3.45, okay, times k squared. The value of k is 1 on what? 20 all squared. Then it means that the value of R02 will now be equal to 0.009 plus 0.0086, okay. So it means that the corresponding R02 will now be equal to 0.0176 ohms, okay. Don't forget to bring the units. Okay. Well, let's look at III. III states that we define the equivalent resistance. III states that we define the equivalent reactance as referred to the both primary and secondary. Okay. So let's do it here. Since we have more space here. Equivalent reactance as refers to both primary and secondary. So we are now going to find III. We state that we find equivalent reactance. So that's what X01. Okay. X01 means that we already have X1, but then we are bringing X2 prime to come and do the referral. So X01 will now be equal to X1 plus what? X2 over K squared. Okay. So X01 will be equal to, what's the value of X1? Here, let's go and check the value of X1 from here, which is given by 5.2 plus X2. X2 is 0.015 divided by 1 over what? 20 squared, okay. So here we can say X01 is equal to, so X01 is given by that, and that would then be equal to 11 point what? 2 ohms in all. Now we said as we first go the primary and the secondary. That means that we should have to get X02 there too. And that means that we are doing the referral at the secondary. So X2 is there already. We are now bringing what? X1. And because it's coming as a refugee, we prime it, okay. So X02 is the same as X2 plus, if it is X1, then it's going to multiply by 1 K squared, okay, K squared. So here we can see that what? X02 is equal to X2. Where's the value of X2? 0.015 plus X1 is what? 5.2 multiplied by K squared. The value of K here is 1 over 20, okay. Is 1 over 20 all squared. It means that our X02 here will now be equal to 0.028 what? Ohms, okay. And let's move further to go and check what is there. The question states that what? So now I wish we have all our answer written. So let's try and write all our answers. We have our R01, which is equal to, so that we will not go to the top to refer again. R01 in the question was equal to 7.05 ohms. Now the value of what? R02 was also equal to 0.0176. Now let's look at what? X, right? 01, right? So here we have X01 to be 11.2, and that of what? X02 is also equal to what? 0.0 28. Okay, so let's move on to the next question. The next question says we should find what equivalent impedance are referred to both primary and secondary. Okay, now when we say impedance, we are talking about the total opposition, right? And we know that whenever we draw our vector diagram, we have this side to be the real part, right? And we have this one to be the imaginary part. Okay, let's say x part. Okay, and finally we have our z. So Pythagoras form of it will give us the impedance. So we are talking about z01. So that will be the root of what? R01 squared plus what? X01 squared. So here we can say z01 is equal to. Now what is the parameter of what? R01? We know it to be what? 7.05 all squared, right? Plus what? X01, which is what? 11.2 squared, which will give us what? A corresponding value of what? Here, z01, right? So 11.2, and that will give us what? 13.23 watt ohms. Okay, so let's move on to find z02. Z02 is equal to, so we have r02 squared plus what? X02 squared. These formulas are really important, which will then be equal to. So let me just let it follow so that we can have more space to do the other questions. So let's look at the next parameter, which is what? Z02, which is equal to, here we have it to be R02. We know the value of R02 is what? 0.0176 squared plus what? X02, which is what? 0.028 watt squared, right? And that will also be equal to, so we have 2a squared plus that, and that will give us what? Corresponding value of 0.0331 ohms. Okay, that was what my calculator got. Okay, now the next thing we are going to do is actually the last question. The last question states that what? Let's see if we can do it here. Okay, I can have more space here. And the last question states that what? Total copper loss, first using the individual resistances of the two, and secondly using the equivalent resistances as referred to the what, to each side. Okay, so we know that what, anytime we want to find the copper loss, which is the I square R losses, we can choose to say that we want to find the copper loss at the primary. So I1 squared R01. Sorry. So the copper loss at the primary, that is I1 squared R1. And then we find the one at the secondary and add them together. That's I2 squared R2. Okay. Or we can choose to also say that, okay, we want to, so let's do that first. Okay. So that means here we are going to have, so what's the value of I1? We don't have I1 here from the question. But then from the rating, we can get the value of I1, right? We know that the power rating is the same as what? I1 V1. And it's also the same as what? I2 V2. Okay. So we can say X. So here, if we want to find I1, I1 will be equal to X over V1, right, from this equation. And we know the X is what? 50 kVA. So 50 times 10 raised to the power 3 divided by V1. Here, V1 is what? 4,400. So that will give us corresponding value of what? I1 in the question, right? Here our I1 will be equal to 11 point what? 36 amps. Now let's move on to the value of I2. Here we are going to get I2 to be X all on what? V2. And that will be 50,000 divided by what? The V2, which is what? 221 volts. It means that the value of I2 will now be equal to 227 watt amps. Okay. Now after getting this, we can proceed to find our copper losses. Okay. Now we say that we can choose to do it individually. That means that our copper loss will feature that of the primary. That's PC will be equal to I1 squared R1 will be equal to I1 squared R1 plus I2 squared what R1. So let's do that. That's using the what the individual resistances. So let's look at I1. Here we have the value of I1 to be 11.36 squared multiplied by the value of R1. And we know that of the R1 is what? 3.45. Okay. 45 plus using what? I2 squared. And we know that the value of I2 is actually 227 squared times what? 227 squared times what? R2, which right times R2, sorry, here, which will give us what? R2 is 0.009. 0.009. Okay. So it means that the copper loss will now be equal to 910 watts, okay, or its approximate value. Okay. Or we can choose to say that now the copper loss is the same as what? You taking the copper loss within the primary alone. Okay. Because we already established that anytime we do the referral, it makes computation more easier. So we can choose to say that I1 square multiplied by what? R01, and that will be enough, because doing the referral in the primary means that the resistances that will cause loss in the secondary has now been taken to the primary. So all the formulas, the resistances are featured within the R01. So we can see we know the value of I1, right? Which is 11.36, right? Multiplied by R01. Here the value of R01 was, let me check my value for R01, which was stated earlier. R01 is given by 7 point what? We had 7.05 ohms. Okay. So this will be I squared. Okay. So here we still get the copper loss to be a very nice value. That is 11.36 squared times 7.05. Okay. That will also give us what? 910 watts. You can also get a value that is close to it. That's fine. You get 909.99. That's okay. So here we can also get the copper loss. We can also choose to use the secondary. That's what the question is saying. The secondary I2 squared R02, because if you talk about R02, it feature R01 too as well. So we can talk about I2 squared. I2 is what? 227. So 227 squared. This value multiplying R02, and R02 is what? 0.0176. Okay. And that will give us the copper loss to still be equal to 910 watt. Okay. Thank you very much, and then we are going to meet in our next question. So that is just all under the referral. It's so easy. You just need to understand the concept of the formulas, and you will be free to go.